Simplifying radicals. I'm going to review a few of the examples from the worksheet here, just to make sure you understand some of the properties and rules for simplifying radicals. So on your worksheet, if you look at number 7, that's what I'm going to go through first. What we're looking for when we simplify radicals is any perfect square factors. So with 75, there's a perfect square factor that goes into 75. 25 is a perfect square. So we break up what's under the radical into a perfect square factor and another factor. Then using the product property, if you have two things multiplied under the same square root, you can take the square root of each separately, individually. And so then what you get is the square root of 25, which is 5. And then the square root of 3 times the square root of 3, which when we have the number next to the square root, that's implied that it's multiplication, just like variables. And then once you get to that point, if there's nothing else under the radical here that can be simplified, if there's no perfect square factors under the radical anymore, then you're done. So this is the answer to number 7. It's 5 square root of 3. So that's kind of the first thing we look at. We kind of do the same thing with variables here. So if you look at the next example, number 8, we look at the square root of 36. That's already a perfect square because the square root of 36 is going to be just 6. Then what you do with the variables, each variable, when you take the square root of x to the 4th, it's asking what times itself equals x to the 4th. Well, this x squared times x squared equals x to the 4th. So the square root of x to the 4th is simply x squared. So if you have an even exponent, basically all you have to do is divide that by 2. If you have an odd exponent, you have to sort of divide that by 2, but there's always going to be a remaining one left. So if I take 9 divided by 2, I get 4.5. So this is going to be y to the 4th, and then that 0.5, that's the extra y that goes under the radical. So again, this is all review of things that you worked on in algebra, intermediate algebra. So if you need more review than what I'm giving you on this little video, then please just reach out and ask some questions. The next one I want to go through is number 9, because a radical is not simplified if there's a fraction under the radical. And so just like when we had the product property, if we have division under the radical, we can give each, the numerator and denominator, their own radical. So then this becomes the square root of 8 over the square root of 3. Now there is still a perfect square factor that goes into 8. But before we worry about that, one of the other really important things to remember is that a radical is not simplified if there's a radical in the denominator. So what you need to do is you need to multiply whatever that square root is on the bottom over itself. That really just has a value of 1. The square root of 3 over the square root of 3. Anything divided by itself is 1. So now when I multiply these together, I kind of use the reverse of the product property. And this is going to be the square root of 8 times 3 under the same radical. And then it's going to be the square root of 3 times 3 under the radical, or 9. So the square root of 9 is simply 3. Any square root times itself is just the number under the radical. And then what we get under the radical on the top is 8 times 3, the square root of 24. But that's not simplified anymore, or quite yet, I guess, because there's still a perfect square that goes into 24. 4 goes in there. So we still have to do some more simplifying, because in order to have a radical in simplest radical form, there can be no perfect squares left under the radical, there can be no fractions under the radical, and there can be no radicals in the denominator. So those are the 3 things you need to check for. And in this example, we still have a perfect square that goes into 24. So now what this is going to become, I'm just going to scribble this one out for now, is going to be the square root of 4 times 6 over 3. And then again, I use that product property where I give each of these their own square root. And so what this becomes is the square root of 4, which is 2, square root of 6 over 3. So that would be your answer. The other thing to remember too is once you get to this point, if you have a fraction right here, if you can reduce this fraction, you do. In this case, 2/3 can't be reduced, so I would just leave that. And then I'm going to go up one example to number 6 and do one more example. This, there is no perfect square under the radical, but again, we cannot have a radical on the denominator, in the denominator. So again, I don't have to multiply by all of this. I just need to multiply by the radical itself. So I'm going to multiply by the square root of 6 over the square root of 6. And when I multiply that together, I would get 5 square root of 6 over, and then I have 3, remember that's 3 times the square root of 6 times the square root of 6. Remember that's just the square root of 36, which is 6. So you end up with 3 times 6 underneath, which is going to give you 5 times the square root of 6 over 6 times 3, 18. And again, that fraction can't be reduced, but sometimes it can. So that's what I wanted to just go through, a few of the sort of nuances or properties and rules to simplify radicals. Again, reach out if you